Today we're going to talk about quadratic transformations. Hopefully in your head you're thinking, oh yes, I know that a quadratic function is the shape of a parabola. It's a U shape. It either goes up if it's positive or goes down if it's negative. So today we're going to learn what the word transformations means. Transformation means that it's going to change. So if you've ever heard someone talk about when they lose weight and then they have a transformation, it means that they will typically show you what they looked like before they lost weight, and then you'll get to see a new picture of them after they've lost the weight. So today we're going to see how a quadratic function will change and how it changes, and we'll see those two pictures. Okay, so the first thing we have to start by knowing when we do this is that the parent function or the original function is f of x, which we know is the same thing as y equals x squared. So that's going to be our parent function. That's going to be what we're always going to compare our new function to talk about how it changed. Okay, so again, I've defined for you the parent function. It's the original function before any changes. And what we're going to do today is we're going to practice graphing a quadratic function, which is y equals x squared, and we're going to use a website called desmos.com. Now you can just watch me as I do this. We'll practice this together tomorrow in class. But what I have pulled up is I have the Desmos website, so I'm going to make this so we can see both at the same time. Okay, so maybe I might have to make it bigger. Alright, so I'm going to type in x and then I'm going to type in squared. So we can see that the first function, y equals x squared, is a parabola. It's going up and the vertex is at the point 0, 0. Now, let's talk about how if we were to graph negative x squared, that's going to change. So I'm going to go to my second function. I'm going to type in negative x squared. How did this change? What did it do from the original or the parent function? Hopefully you're saying to yourself, it reflected over the x-axis. However, the vertex is still the point 0, 0. Okay, so that's what we're going to write here is we're going to write that the new function or how it transformed is it reflected over the x-axis. So it looks exactly the same. The only difference is that it reflected. All right, so now we're going to go and we're going to graph 2x squared. So what we're going to do is I'm going to delete this function, the negative x squared, because what we're doing every time we're talking about how a quadratic transformed is we're comparing it back to the original parent function. So we're always comparing it back to the x squared. Okay, so I'm going to type in 2x squared. All right, so now let's talk about the red function is my parent function. The green function is the new or the 2x squared. What did this function do? Okay, so let me make it bigger so we can look at it more closely. You could say that it got narrower. Okay, the red function is the parent. The vertex is still at the point 0, but the green function got narrower. Okay, so that's what we wrote there. So the next thing we're going to do is we're going to graph x squared plus 3. So again, I'm going to go back over here. I'm deleting this function because every time we're comparing it back to the parent function. So I'm typing in x squared plus 3. Okay, so now we're looking at how did the orange change from the red? What did it do? Look at the vertex. The vertex for the red function or our parent function is the point 0, 0. When we talk about the vertex of the new function, the x squared plus 3, the vertex is the point 0, 3. And you can tell that by moving your cursor up. Okay, so what did it do? It moved up 3. Next, we're going to graph x squared minus 3. So when we come over here, we're deleting this function. We're leaving our parent function, and now we're typing in x squared minus 3. And we're going to talk about how that changed. How did the blue or the purple function change from our red function? Remember that the red function is our parent function. It went down 3. So we're looking at the vertex. How did the vertex change? This is my original vertex for my parent function. Here's my new vertex. Remember that the vertex is where the graph changes direction. Next, we're going to graph in parentheses x squared minus 3. Okay, so I'm deleting my function. I'm retyping in x minus 3. I'm going outside the parentheses and I'm typing in squared. How did this change? It moved to the right 3. So again, I'm basing this on the vertex, so it moved right 3. Okay, the next one, we're going to do the same thing. The only difference is we're changing this to x plus 3. So I'm deleting this function, leaving the parent, and now I'm typing in x plus 3 and outside the parentheses squared. And then we can see now these actually happen to both be the same color, but we know that our parent function vertex is always at the point 0, 0. So what is the point of the new vertex of the transformed function? It moved to the left 3. Okay, so we actually can talk about how these functions all change, and we're going to do that using this function. So hopefully you noticed as we were moving through these examples that sometimes we had a number in front of our x squared. So for example, this was a -1, this was a 2. Okay, sometimes we had a number after the x squared, and sometimes we had parentheses and we had something shortly after the x but before the squared. Okay, so we can talk about this as this being our negative or a number in front, this being our number after, and this being our number in the parentheses. And there actually should be a squared right here. I'm going to add this in. Can you please add this to your notes? Okay, so if there is a number in front of the x squared or the x, and it's larger than 1, it could either mean that it's getting wider or narrower. So any number out in front is going to make the graph either become wider or narrower. Now the other thing that I should add here is narrower or reflect over the x-axis. Please add that. I'm going to have to make this smaller. Okay, wider or narrower or reflect over the x-axis. Now, if there is a number inside the parentheses, it's telling us that it's either going to move to the left or the right. And if there's something outside the parentheses, it's going to move up or down, and that would be your k value. Okay, we're going to practice this more in class, but here's your notes on transformations. You can stop there and we will complete your practice together when I see you in class.